All right, we are ready to go. Good morning and welcome to our continued discussion on divisibility, exploring the integers and see what makes them interesting and what makes them different from each other by way of divisibility tests. So let's write here divisibility test. Whoopsie. Tests is what we are discussing. And overall, we're looking at the test for 2, 3, 4, 5, 6, 7, 8, 9, 10, and we'll stop at 11. Now we've started with the very familiar 10, 5, and 2, and because they all have a similar test in that I look at the last or the rightmost digit. And based on that, I can determine what is happening to the whole number, regardless of how big it is. Then, hopefully, I uploaded the video last night. Hopefully, you had a chance to look at it. We looked at 4 and 8. And notice that for 4, we need to look at the last two digits of a number and nothing else to decide if 4 can fit into that. And for 8, it was similar, it wasn't ideal. It's the last three digits, which does slow me down a little bit, but it's a similar test and it does shorten the number that I have to look at, my comparison number, so to speak. And then we also looked at 3, and we saw that we wanted to do something similar to 4 and 8, but 3 is just not the same kind of number. And we had to pull the number apart much more. And what we ended up with is that our comparison number is the sum of all the digits. So next we'll do the test for 6. There might be an overlap if you watched the old video that I uploaded and you didn't want to wait, then there might be an overlap. But I only got as far as 3, so I have to do 6 and 9 still. Now, the good news is that the test for 6 is quite easy. A number is divisible by 6 if and only if it is divisible. Ooh, my writing is not good today. Is it ever good, really? By both 2 and 3. So I need to, in order to decide if a number is divisible by 6, I need to check if it's divisible by 2, if it's divisible by 3, and only if I have both, then I can say, yes, it's divisible by 6. For example, let's take here 312,798. Is that divisible by 6? Well, I need to decide, is it divisible by 2? Yes, because my last digit is an 8. It's an even number. Is it divisible by 3? Well, I don't know. My comparison number is the sum of all the digits. 3 plus 1 plus 2 plus 7 plus 9 plus 8. What do I get here? I get 4, 6, 13, 22, 30. Oh, wow, that's very nice. So that is a yes as well. So I get yes on both checks, and therefore it's divisible by 6 is a yes as well. But as soon as one of them fails, let's suppose I had a different digit here, my comparison number isn't divisible by 3 anymore, Even though it is even, it's not going to be divisible by 6 anymore. For 6, I need both 2 and 3 at the same time. Now, this isn't hard to remember, and certainly it has got something to do with the fact that 2 times 3 equals 6. But please don't read into this more than there is. This is the test for 6. And it is because 2 times 3 equals 6. And because of 2 and three's relationship to each other, which I can't go into right now. I can't take this and say that, oh, if I have two numbers that multiply to something, let's say 2 times 4, 2 times 4 equals 8. So if I want a different test for 8, because I don't like checking 3 digits, it's annoying, why can't I then take this and extrapolate that to say, well, if the number is divisible by 2 and the number is divisible by 4, then it's divisible by 8, because 2 times 3 is 6 and it works for them. 2 times 4 is 8. Why doesn't it work for that? I have to be very careful to not let one example of this kind of test take my inductive reasoning thinking and make me think there's more than there actually is. Can we come up with an example of a number that is divisible? Look for some number n. I want it to be divisible by 2. I want it to be divisible by 4, but I want it to be not divisible by 8. Therefore, giving me an example that contradicts my thinking to go further with this test for 6. Just because two numbers multiply together, if I have divisibility for each one, that doesn't mean I have divisibility for the bigger one. Can I come up with an answer or an example that would satisfy these 3 requirements? It's not hard to find. It doesn't even have to be big. 12 will work. 12 is divisible by 2. 12 is divisible by 4. It's not divisible by 8. So very, very easily, there are examples that show that this way of thinking that the test for 6 gives me can't necessarily just be generalized for anything. I can use 2 times 3 equals 6 to remember this test, but don't run with it and think, oh, now it works for everything. No, there's a special relationship between 2 and 3 that make it work. And we can come back to this if you remember. Ask me at the end of the next chapter. There is something more to this, but at this stage, I don't have the knowledge to just take this further with confidence and 100% certainty, like this example shows. All right. So that finishes 6. Not bad, not bad. Next up is 9. I apologize if you have seen this before, because even though it's a different number, 9, we actually save a lot of effort, and it turns out to be very similar than 3. Let's remember what the test for 3 was and why. More importantly, why. Now, I will say again that you do not have to be able to explain, by way of an example, why the test for 3 is what it is. But in order for me to explain 9, I have to just take an example and do it. Let's say 42,578. What did we do for 3? It is nice, for me personally, to have an understanding of why the tests say what they do. Whether it's being tested in a quiz or not is kind of irrelevant for my personal growth in terms of the knowledge that I have. So I'm going to say 40,000 and then 2,000 and then 500 and then 70 and then 8. So 40,000 is 4 times 10,000. 2,000 is 2 times 1,000. Then I have 5 times 100, 7 times 10, and 8. Now again, just like for 3, I noticed that 9 doesn't like 10,000, 1,000, or any of those multiples, those powers of 10. But what I'm going to do is write 10,000 as 9,999 plus 1. And then 1,000 as 999 plus 1. And then the 100 will be 99 plus 1. And the 10 will be 9 plus 1. And I'll squeeze in the 8. Now I'll separate it in the same way as I did before and reorder them. I'll just save that step because it's exactly the same as we've seen when we explored a test for 3. Everything is exactly the same. I'm just doing it again so I have something to look at. And the other things here I have is 4, 2, 5, 7, and 8, which we eventually noticed are the sum of the digits. So, not 4. 9 is what I'm looking at. 9 is going to divide into 9,999. Obviously, 999. It's going to divide into 99. It's going to divide into itself. Everything is good. So any multiple of these will be good. Then when I add them together, it's going to be good. Everything is going to be good. So this first portion is always divisible by 9. Therefore, the divisibility by 9 of the original number only depends on the sum of the digits again. So really, I get 2 tests for the price of 1, for the effort of 1, in that it's exactly the same test. But I now need to check my comparison number. So my comparison number, that was supposed to be an M. It doesn't look very good, does it? Let's get rid of it. Wow, I cannot write an M today. What is happening? M. Comparison number is 4 plus 2 is 6, plus 5 is 11, 18, 26. I test this 26 against 9 and say 9 does not divide into 26. It was close though. It's 27 and I would have had it, but it's not. So therefore I conclude that 9 does not divide into my original number. So even though the test is the same kind, I'm looking at 9 in this case. So let's write that down. So it's my divisibility test for 9. A number is divisible by 9 if and only if the sum of the digits is divisible by 9. So exactly the same phrasing, but it is in relation to 9, not 3. I'm just going to be right back. I just need to close a window. It's getting a little drafty. Be right back. Okay, so we're getting pretty far in this list. 9 is done as well. Next up is going to be 11. Now for 11, I just need to open our book, see if I have it here. I have to find an example because the phrasing of the test for 11 is going to be a little unpleasant. It's just going to be a little messy. In order for me to help phrasing the test, the words that I'm going to write out, I'm going to need exercise 9.3. It's not hard. It's just to clarify what we're going to mean with the words. So if I look at a number, I'm going to introduce the concept of a decimal position of a digit. So I'm just going to copy this number to do a little bit more than the exercise does, but we'll do that exercise to clarify what we mean. Okay, so here's my example number. 5,187,535. Big number. Okay. So I'm going to number, actually, I'm going to write this way bigger. Way bigger. 5,187,535. Each of these digits are in a specific position, a place in this number. I'm going to number these positions. So this is going to be my position, actually my decimal position. And I'm going to number them right to left, 0, 1. I'm going to put them in brackets so we don't mix up what's the original number and what is the position. 5 and 6. Now, this isn't just random. This number fits the power of 10 that that place corresponds to. This is the hundreds place. 10 to the power of 2 is 100. Okay. I'm going to call that the decimal position. So if we now look at exercise 9.3, 1a, I have my number and it asks me, what is the digit in decimal position 2? Decimal position 2 is this guy. The digit is 5. What is the digit in decimal position 5? I go to position 5. Digit is 1, 1. So it's not a hard concept, I hope. What is the digit in decimal position 0? Decimal position 0, it's a 5 again. And then over here, number 2. Now the other way around. What is the decimal position of the digit 1? Well, the digit 1 occurs in position 5. Its position is 5. So even though the answer looks the same for 1a and 2a, those 5s are completely different. This 5 was a position. This 5 is a digit. Or the other way around. The other way around. The first 5 is a digit. The second 5 is a decimal position. Either way, they're different. I forgot my own question. Next up, determine the decimal position of the digit 3. So the digit 3 occurs in position 1. And lastly, what is the decimal position of the digit 5? Well, there are many 5s. 5 occurs in position 0, 2, and 6. So because digits can duplicate, can appear more than once, I can have multiple decimal positions for a specific digit. Right. So we're only doing this to make the phrasing of the upcoming test for 11 as nice as I can make it. This is one way of doing it, and I found it to be the least confusing. Okay, so hopefully decimal position doesn't confuse you too much. I only need it for the phrasing. I'm just numbering the places of the of the number. Okay. So now let's take an example, and I want to do something similar to what I did for the test for 3 and 9. Let's take an example here, 52,379. Why not? Random example. I'm going to start the same way. I'm going to say 50,000 and 2,000 and 300 and 70 and 9. And then, of course, there's no doubt it's going to be 5 times 10,000, 2 times 1,000, 3 times 100. I do have a decimal number, so can I squeeze in the 9? Yes, I can. So that is how I'm going to pull this number apart. There's not much else I can do. Now I have to note that, let's start small. 11 doesn't go into 9. It doesn't go into 10. Okay, so first of all, it doesn't go into 10. So I have to do something with that 10 next to my 7, because 11 doesn't like 10 as it is. Now that was the same in the case for 3 and 9. And what we did was we changed it to a 9 plus 1. But 11's not going to like that, because 11 doesn't fit into 9. I'm going to have to go the other way and realize that, okay, 11 does fit into 11. So this 10 I'm going to write as 11 minus 1 in order to get a number in there that 11 likes. For 100, 11 does like 99, and it doesn't like 101. So for the 100, I can go 99 plus 1. It's going to be okay. When it comes to the 1,000, 11 doesn't like 999, unfortunately. But it does like 1,001. So for this one, I'm going to go 1,001 minus 1. And for 10,000, I realize that 11 likes 9,999, so I can go that plus 1. All right, so now let's do that. 5 times 9,999 plus 1. I like to write it out so I can see it, and it gives me some time to just understand what is happening here. If I have any questions or whatever the situation may be. Okay, so that is what I have so far. Now I'm going to multiply the front numbers in. 5 times 9,999 plus 5, 5 times 1. Then 2 times 1,001 minus 2, because it's a minus. Then plus 3 times 99 plus 3. And then I have 7 times 11 minus 7 and plus 9. Okay. Now I'm just going to regroup. All the messy ones will go together. 2 times 1,001, 3 times 99, 7 times 11, and then everything else. 5 minus 2 plus 3 minus 7 plus 9, and so on. So I have these two groups. Actually, let's do some color. Let's get some color in here. Oh, the cat is left outside. Oh, poor guy. And it's cold out there. So now I realize, okay, 11 is happy with all of these guys, which means any multiple of them. And when I multiply them together, 11 is going to be A-OK. So this pink portion is always divisible by 11. It's what's left that's going to decide my divisibility by 11. And it's only going to depend on this. Now, the question is, where does this come from? Well, it's the digits again, but not quite the same as before. I don't add them all up. Unfortunately, I don't add them all up. They seem to have alternating signs. Plus, minus, plus, minus, plus, minus. Now looking at the situation, if I added another digit here, at this is 100,000 digit, let's call it 6. What would the sign of that 6 be as I follow this through? It's going to be a minus. So I don't want to go left to right because the left digit sometimes has a minus, sometimes has a plus, depending on how long the number is. But the ones digit will always have a plus because it's always on its own up here. It's always going to be a plus. The next one is always going to be attached to 10, which always gets a minus. So if I go right to left, I'll always go plus, minus, plus, minus, plus, minus. Should I get rid of this 6? It wasn't in the original example. Let's get rid of it. Regardless, my comparison number in this case is 5 minus 2 is 3, plus 3 is 6, minus 7 is -1, plus 9 is 8. 11 does not fit into 8. So I conclude that my original number is not divisible by 11 either. Whoopsie, that's not where the comma goes. That's where the comma goes. Okay. So it's similar to the test for 3 and 9, but it's a little bit more complicated in that I'm alternating plus, minus, the digits. It's not adding them up. Okay. So now let me just look at this a little bit and decide how are we going to phrase this. What was my example here? 52379. 52379. My decimal positions were 0, 1, 2, 3, and 4. My comparison number, starting from the right, 9 minus 7 plus 3 minus 2 plus 5, and it'll continue if there were more. So the test for 11. A number is divisible by 11 if and only if, it's the only test I need, oops, why is that capitalized? The sum of all which decimal positions get pluses, all the even ones get pluses, of all digits in even decimal positions minus all digits in odd decimal positions if that number is divisible by 11. Okay, so however you want to phrase it, I'm not going to ask you to phrase the test for 11. You just have to be able to use it. So regardless of how you want to remember it, using the decimal positions as a reference to where the digits sit is one way to phrase the test in as clean a way as possible. It's not the only way, but it's a way that will be effective. You just have to remember. So when I actually do the test, I just remember start with the ones digit, work my way left, and start with a plus. So I have the ones digit, and then I start minusing, like this. There's one more example that I need to note. Let's actually see the test here. Now I'm just going to make it up to make sure it works. Let's think here for a second. I'm going to make up an example. Let's say 9. I was going to make an obvious example. 2, 2, 4, 4. So 992,244. It's hard to come up with something that works in my head that is not obvious. So the question is it divisible by 11? So my comparison number is going to be starting right to left, 4 minus 4 plus 2 minus 2 plus 9 minus 9. My comparison number is 0. Is this number divisible by 11? Well, let's sort of cheat a little bit. Let's cheat for a second and use my calculator to divide this number. 992244 divided by 11. It is divisible by 11. So 11 does divide into 992,244. So when I have a comparison number of 0, the answer is actually a yes, because 11 divides into 0. What is my divisibility definition? Remember, B divides into A if there exists an integer q such that I can write it in the quotient remainder form with no remainder. No remainder. Well, in this case, B is 11. A happens to be not bigger, though intuitively I think of A as bigger. There's nothing that ever says it has to be. A happens to be 0 in this case. Is there a q so that I can write A equal to q times 11 plus 0? Yes, there is. It's 0. It exists. And therefore, technically, though maybe not intuitively, technically 11 divides into 0, or 0 is divisible by 11. 0 is special, right? So I just want to be very aware that if I get a comparison number, in the case for 11, because I'm plusing and minusing, I could get a 0 as my comparison number. If I do, that's a good answer. It's a divisibility yes answer for 11. Though it might not feel like, how on earth can 11 fit into 0? Yes, 0 11s fit in, and nothing is left because there was nothing. So it is a technicality, but it does fit the divisibility requirement. Okay. All right, we are moving along, and actually we're at the end. We're at the end because it turns out that 7 does not play well with others. And as you explore different topics within math, 7 is very often the one that is the most problematic. He just doesn't want to play. He just doesn't want to have a nice test. All the other numbers, pretty much, said, yeah, we have pretty efficient divisibility tests. It's not going to be a lot of effort to answer our divisibility question. 7 says, no, I don't want to be like that. I'm going to make it difficult for you. And it turns out that though there are divisibility tests for 7, they do not actually save me time. The work that goes into them is pretty much the same amount of work if I just did the long division. And the whole point of the tests are these tests are there to save me time, that I don't have to look at this long number. I can just look at a portion of it, be it the last digit or adding up the digits real quick, something efficient, something small, something fast. And then I can use that to make my decision. 7 says, no, I'm not going to do that. You're gonna struggle. So for that reason, I'll mention the test for 7. It's not intuitive in any way, and justifying it is going to take the formal proof way, which is in the book if you're interested, but I don't expect you to follow it perfectly. So if you're interested, it's all in the book, but I don't want to add confusion by going off on a tangent just for the sake of 7, because he doesn't want to play with us. I'm not going to be a 7 enabler. Divisibility test for 7. So let me think. Maybe an example is going to be better to understand. And I'm actually going to leave the phrasing to you. It's not worth, 7's not worth my time. He doesn't want to play. I'm not going to play with him. So I'm not going to try and phrase it in the most elegant way possible, but I'll do it by way of example. So let's take an example. Let's say 52,723. Now, I can't look at the last digit. I can't look at the last 2 digits. I can't look at the last 3. I can't add the digits. I can do none of those things when it comes to 7. As much as you may want to, math isn't really about what I want. It's about what is true. How it works is I am going to split this number up. I'm going to I'm just going to cut off the last digit. There it is. And then I'm going to take the number as if that last digit was never there. And then I'm going to subtract that last digit times 2. Why? Well, because the proof says so. And the proof is not the simplest thing at this stage for us. Then I'm going to get an answer. That answer is my comparison number. Comparison number. What do I get here? I get 5,266, right? Because I subtract 6. Now, because I subtracted so little, it's always going to be single digit number, maybe something a little bigger, but I'm only taking that last digit and subtracting just 2 times that. I'm always going to get a fairly big number still, especially if I started with something big. So the whole point of a test, right, is to avoid the long division. So I can then say, oh, well, okay, now I need to decide if this number is divisible by 7. So I'm going to do it again. Take the last digit, take the number as if that last digit was never there, subtract 2 times the last digit. What do I get? Well, this time I'm subtracting 12 at least, a little bigger, not much. And I get 514. Maybe that's still too big, because I remember for 8, looking at a 3-digit number still required a little bit of a long division. There was no way around it. I then look at the same thing. Take the last digit. Take the number as if that last digit was never there. Subtract 2 times that number. Oh, 2 times that last digit. What do I get? I get 51 minus 8, which is 43. So I can then say, well, 7 does not divide into 43. It's close, but unfortunately not. Therefore, 7 does not divide into the previous comparison number. Therefore, 7 does not divide into the previous comparison number. Therefore, 7 does not divide into my original. That's the test for 7. Now, one of them. The others, I don't even remember them because they're arbitrary. They're just there for the sake of having a test. They don't benefit my life in any way. This is not efficient. Look how long this took. I could have just done the long division because how slow would that be? I'm much more proficient in long division. What was the number? I don't remember the number. 52723. Compare the time that that took versus just doing the long division. That's good practice. Let's do it. 7 goes into 52. 7 times for 49. If I want to speed up and just scribble it for myself, of course, I don't need to write all the zeros, right? I'm not teaching it. Then I have 3 left, so I have bring all down all the other numbers. 7 goes into 37 5 times. To use 35, I have 2, 2, 3 left. 7 goes into 22 3 times for 21, and I have 1 left. 13 once using 7, and I have 6 left. Remainder not divisible. That was way faster because I played to my strength and I did this. I've done this many, many times. Now, if I took a big number and I compared the time that the other divisibility tests take for 2, 4, 6, whatever, versus the long division, those actually save time. They're worth knowing, worth using, worth adding to my knowledge. This one is there for the sake of being there. It doesn't actually make my life better in any way. So it's there if you're interested, but I am not going to ask you to apply the test for 7 ever in any test. So the numbers we have to know are 2, 3, 4, 5, 6, 8, 9, 10, and 11. All right. That is the end of our divisibility test discussion. Now we have 4 minutes. What I actually want to do is give you some time, give you the rest of the day, or whenever you watch this, to think about these tests and at the very least understand that each one has a somewhat different test. I can't cross over and use one test for a different number. Each one has its own test, and I have to remember them. And I have to right away know if I'm working with a 4, the test is to look at the last 2 digits. It's nothing else. And if I look at any other number, it's not that test. Each one has its own test. And then at the start tomorrow, we will look at exercises 9.4, 9.5. You're welcome to look at them in advance to see if you have any questions. But I just want to make sure that everyone has the tests nice and firmly memorized so that when we need to recall one, it's very quick and immediate and effortless. Okay. You're welcome to look at the problems. We'll continue the discussion after those 2 examples, moving into the next chapter. Actually, no, I need to look at the schedule, don't I? Let me just pause for a second and look at our schedule before I say the wrong thing. Let's look at the schedule here. We have 2 minutes. Let's be sure what's coming up. Let me open it here. I think I am a little bit confused, which is not surprising. I do get confused very easily. We are still in October. I at least know that. That's progress. We are over here on Thursday, right? It's Thursday. I'm pretty sure. Thursday, divisibility test. Okay, so we are only moving on to the next chapter on Monday. So forget what I said there. So on Monday, there's a video for you to watch on the next chapter of prime numbers. So we're not going to get ahead of ourselves. Tomorrow, I am doing the exercises I mentioned. We can do some problems, we can answer any questions, but that is what we're doing tomorrow. So we do have a day. Half of it will be catch up. If you have questions, bring them. Otherwise, I'm just going to do exercises and problems and make sure we understand this divisibility test uh, idea. Okay, so that is happening tomorrow. So some practice is happening tomorrow. Any questions on what we are doing tomorrow versus what's coming up? I don't think I contradicted myself. We are doing the exercises and maybe some more tomorrow. All right, are there any questions before we call it a day for now? Assuming that everyone still heard me. I always have this paranoid idea that I do a whole lecture, but actually my mic was off the whole time and no one said anything. And I was just actually
Uh,
talking to myself.
I can hear you. It sounds good.
It's gonna happen one of these days. I'm telling you, it's gonna happen. Okay, so maybe I see you tomorrow, maybe not. It's all good. If I don't see you, enjoy the weekend, and we will chat next time. Until then.